Hi and welcome to section 2.4 for Econ 1 on the AQA exam board. Today we'll be looking at cross-elasticity of demand and we'll be looking at complementary goods and unrelated goods. In the previous video we looked at complementary goods and we introduced the formula for cross-elasticity of demand. We'll just recap what cross-elasticity of demand is and what the formula is and the relationships between goods. Cross-elasticity of demand measures the responsiveness of demand for one good following a change in the price of another good. It is worked out by using the formula cross-elasticity of demand equals change in the quantity demanded of good B divided by the change in the price of good A. There are three types of relationships between goods. One relationship is substitute goods. These have a positive value for cross-elasticity of demand. So when the price of good A rises, the quantity demanded of good B also rises. The opposite happens when we have a price fall in good A. If the price of good A falls, the quantity demanded of good B will also fall. Another type of relationship between goods is complementary goods. And the final type is unrelated goods. We'll be looking at complementary goods and unrelated goods in more detail later on in this video. Let's start by looking at complementary goods. Complement goods provide high utility when combined with another good or service compared with being consumed on its own. An example would be bread and butter, burgers and burger rolls, and wine and cheese. We're going to use the example of bread and butter, and we're going to suppose that the price of bread increases, and we're going to see what effect this will have on the demand for butter. So here we have the demand for bread. Initially, the price for bread is at P1, which leads to a quantity of Q1 being demanded. We also have the market for butter. Initially, the price is P1, which leads to a quantity of Q1 being demanded. The price of bread rises, which causes a movement along the demand curve, which leads to a lower quantity of bread being consumed. Quantity Q2 of bread is now being demanded rather than Q1, which was when the initial price was P1. As less bread is being demanded in the economy, there is less demand for butter because there is less bread to spread it on. This causes the demand curve for butter to shift inward from D1 to D2. If the price of butter was to remain constant at P1, there would be a new equilibrium in the economy with the new demand curve, where a lower quantity of butter will be consumed, Q2 rather than Q1. So the increase in the price of bread has led to a decrease in the quantity demanded of butter. The price of bread has rose from P1 to P2 and the quantity of butter has fallen from Q1 to Q2. So let's have a maths example. We're going to use two different complementary goods here and we're going to use wine and cheese. Wine is good A and cheese is good B. Suppose that wine increased in price by 20% and this resulted in the demand for cheese to fall from 50 tonnes to 35 tonnes. What is the value for cross-elasticity of demand? So we've got the formula, which is percentage change in quantity demanded of good B, which is cheese, divided by the percentage change in the price of good A, which is wine. So the percentage change in price is given in the question, that's 20%. And the percentage change in quantity demanded of good B is minus 30. We get minus 30% by doing the new quantity demanded, which is 35 tonnes, minus the original quantity demanded, which is 50 tonnes, divided by the original quantity demanded, and then we times it by 100. So it's 35 minus 50 divided by 50 times 100 gives you minus 30%. Cross-elasticity of demand is then worked out by doing minus 30 divided by 20, which gives you a value of minus 1.5. A negative value for cross-elasticity of demand indicates that the two goods are complementary goods. If there was to be a price decrease for the wine, then we would still expect a positive figure for cross-elasticity of demand. This is because a decrease in the price of wine would cause an outward shift in the demand for cheese. An outward shift in demand for cheese would cause a greater quantity to be consumed in the market. So the price of wine is decreasing, which is a negative %, and the quantity demanded of cheese is increasing, which is a positive. And a positive divided by a negative gives a negative value. Therefore, complementary goods will always have a negative value for cross-elasticity of demand. Like we had with substitute goods, we can have close and weak complementary goods. A close complement will experience a large rise in demand after a small fall in the price of A. On the other hand, a weak substitute will experience a small rise in demand for good B after a relatively large fall in the price of A. The value for cross-elasticity of demand for close complementary goods will be a greater negative, i.e. maybe a value of something like -2, -3. Weak complementary goods will have a value that is closer to 0, but is still negative. For example, a value of -0.5 or -1. We can draw a diagram which plots the price of good A on the y-axis against the quantity of good B demanded. Close complements will have a fairly flat line. This is because a small decrease in the price of A will result in a large increase in the quantity demanded of good B. Weak complements will have a steeper but still negative sloping line. This is because the same decrease in the price of good A results in only a small increase in the quantity demanded for good B. As the value for cross-elasticity of demand approaches 0 and is moving from a negative number, the line becomes steeper. Another type of relationship between goods are unrelated goods. A change in the price of carrots will have no effect on the demand for hockey sticks because these two goods are unrelated. Therefore, the coefficient for the cross-elasticity of demand will be 0. This is because demand will not respond to a change in the price of an unrelated product. So here we have the market for carrots. We have an increase in the price of carrots, which causes a movement along the demand curve. A price of P2 leads to a lower quantity of carrots being demanded. But like I have already said, the increase in the price of carrots has no effect on the demand for hockey sticks, and therefore D1 is equal to D2. And this leads to the same quantity of hockey sticks being demanded. Here we have a number line to show what the values for cross-elasticity of demand mean. So, unrelated products have a value for cross-elasticity of demand that is 0. The example that we used was carrots and hockey sticks. A positive value for cross-elasticity of demand means that these goods are substitute goods, with a greater value indicating that these goods are closer substitutes, and a value that is closer to 0, a smaller value, indicates that these goods are weak substitutes. We use the example of newspapers with the sun and the mirror to show substitute goods. A negative value for cross-elasticity of demand means that the goods are complementary goods. A negative value that is close to 0 means that these two goods are close complementary goods. The example for complementary goods that we used was cheese and wine and bread and butter. But why do we study cross-elasticity of demand? One reason is so that firms can see the effects of price changes of other goods on the demand for their goods. They will also be able to see the effects that their own price changes have on the sales of other firms. This allows firms to make better informed decisions about pricing and what quantities to supply to the market.